Hi everyone, it's a behind the scenes look at multiplying fractions and whole numbers with counters, and then a little bit later on there will be a lesson on dividing fractions and whole numbers. So first what I would do is always teach using manipulatives and paired with word problems. So the first problem the kids would see is, I have 3 dogs. This week each of them will need 2/5 of a bag of dog food. How many bags of food will I need? And here's my 3 cute dogs, and then modeling out, here are my 2/5 bag of dog food each. And I would probe them to ask them, well, how would we know how much to buy at the store? What would a model look like? How could we rearrange these fractions and put them all together? And hopefully they would come up with something like this. They could either respond on a communicator or a dry erase board working with their partner. Now the hands-on part, you would need double-sided counters. I think there's some red and yellow ones. I had some pink and orange ones. Using the same problems, I have 3 dogs. This week each of them will need 2/5 bag of dog food. How many bags of food will I need? So the way we would lay out the counters in their workspace is this. You have 1 puppy, and you're looking at your numerator. You know that there's 5 parts in this whole, so you need five counters. Now for the numerator, you'll flip over 2 colors. So you have 2/5 illustrated. Now when we're multiplying, we know that we need 2/5 3 times. So here's my second dog, and here's my third dog. What would happen next is we would have the students clear out the pieces that we didn't need, keeping in mind that our denominator is 5. 5 chips make 1 whole. So the kids, knowing that they had 6/5, they would take 1, 2, 3 to make their first group of 5, and then see how many they had left over. So their answer would be 1 and 1/5. Okay, so here's another example of essentially the same thing. Chef Roncal is baking 6 blueberry pies. If she uses 3/4 pint of blueberries in each pie, how many pints of blueberries will she need? So here we go. Here's Miss Rongel's yummy pie, and we have a model, a bar model of 3/4 pint of blueberries. Again, we're multiplying because we know she needs to create 6 pies, and each pie needs 3/4 cup. So we visually see that our numerator is 18 while our denominator is still 4. So here's the problem isolated, and the kids will get their counters out and make 6 groups of 3/4. You would clear away all these blue chips because those are the parts that they're not using, and looking at their denominator, create groups of 4 to get their final answer. So after the guided practice, I would give them this problem. Dr. Jackson pours 3/8 pounds of dirt in each of her 4 flower pots. How much dirt does Dr. Jackson use to fill her pots? I would leave this picture up here to kind of give some context to what the word problem was asking. What I was mainly looking for was that these students would lay out 8 counter chips as their denominator, and then flip the counters for their numerator 3, and then obviously repeat that 4 times. And then the very last problem, I would take away any visual cues and just completely make them, Miss Ritchie had 6 students in her class. She wanted to give each of her students half a candy bar. How many candy bars would she need? And then I would invite a student up to demonstrate for the rest of his classmates what he put or she put. So up next is a really fun lesson to introduce the division of fractions, specifically a whole number divided by a fraction. And what you use to represent those whole numbers are strips of construction paper. So to prep, what you need to do is cut these strips of construction paper all about the same size to represent 1 whole. And I would cut as many as you can because the kids are going to do a lot of tearing and they're not reusable. Another thing is to manage all the materials and the scraps during the lesson. With each pair or each table, put a little trash bucket in the middle of the kids so immediately they can clean their workspace and then drop their little extra pieces into the trash and move on to the next question. And just like before, what we did was we introduced this skill of dividing a whole number by a fraction coupled with a word problem. So first I said you have 5 cups of frosting and it takes 1/3 cup to frost each cupcake. How many cupcakes can you frost? Well, the equation would read 5 divided by 1/3. So you would instruct each of the kids to grab 5 holes or 5 strips of construction paper. Now it tells you that it takes 1/3 of a cup to frost each cupcake. So for one cupcake, we can cut it into thirds. Looking at our denominator, that's our big clue. This needs to be cut into thirds. Now the question says, how many cupcakes can you frost? Well, this is 1/3 of a cup here can frost 3 cupcakes, and we have 5 cups. So you're going to instruct the kids to tear the rest of their holes into thirds and then count the total amount of pieces left over. So then that'd be 1, 2, 3, 4, 5, 6, all the way up to 15. So 5 divided by 1/3 is 15. So here's the same problem just shown in a different way using a dot method. And I really like this because I think it gives a clear visual of how you're dividing a whole, related more to a bar model. And the problem says you have 5 cups of frosting. It takes 1/3 cup to frost each cupcake. How many cups can you frost? Well, we know that the problem tells us you have 5 whole divided by 1/3. So the first step that you do is you're going to draw 5 squares. 1, 2, 3, 4, 5. And each of these represents one whole. We're using a solid line. Now we're dividing each of these 5 by 1/3. Whenever you divide, and this is your second move, I always tell the kids that this is like what you're cutting or you're dividing. So we're going to use a dotted or dashed line to represent our thirds. So here I am dividing it into thirds. And at the end, I have 15 pieces all the way across. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here's another example using the construction paper strips and modeling the answer with the dot method. It says, I need 2 gallons of gas for the mower. If I buy gas half a tank at a time, how many half tanks will fill my container? Now I know that the language in this word problem is a little bit hairy, but it's nothing out of the norm than what the students might see. So let's just break it down. They need 2 gallons of gas for the mower. If you buy gas 1/2 tank at a time, we're going to split this into half. 1, 2, 3, 4. How many half tanks will fill my container? 4. The answer would be 4. 2 divided by 1/2 is 4. Now the dot method, I think, does a good job of visualizing this. In solid lines, you would draw your dividend 2, and then with your dotted line, you would cut each whole into half. And then at the end, just count how many different pieces would you have. So this problem is going to be different. It is the opposite. It is a fraction divided by a whole number. And the best way to demonstrate this is by using the dotted paper. It says Sammy had half of his giant birthday cake left over from his birthday party that he plans to eat the next day. He wants to split it between himself and his brother. How much of the cake will they eat the next day? So step 1 is to model your half by drawing a hole. And then I'm using only solid lines because this is my first part of the problem. And we know that half would be this half. Sorry, my pen's not that thick. And this says Sammy wants to share this with himself and his brother, meaning 2 people are going to share this half. So I'm going to take this half and I'm going to cut it for 2 people. But since we're comparing this part to a whole, this is a spot where a lot of misconceptions come in. Kids will want to answer and say it's 1/2, but that's not true. What you have to do is cut all the way across and compare one part to the whole. And we have 4 pieces, so each child actually gets 1/4 of the cake. So here are some different ways that students can see the same type of problem modeled. The main important thing that you're looking for is you know that you're dividing a fraction first because there's only one whole object, and that whole object has been split up into different pieces, as compared to when they were grabbing the piece of construction paper and you would have each construction paper represented one whole. So here within your whole, like for example this first problem, you have 1/4 that you're dividing into 4, and so it's tempting to stop at the line, but since we are all awesome math teachers, we know that we need to compare our part to the whole. So here I'm dividing it all the way down, and then I can clearly see that the answer is 1/16 and not 1/4. I would try to demonstrate doing the same thing on the circle. It's going to be very messy, so just bear with me. If we cut this half into 1/6, I know that I would need to do the same all the way across. So here we go. Uh-oh, I knew there would be problems. So looking at just one slice of this pie, we know that it's 1/12. And then I'll just show one more time. However your solid lines are, just always draw perpendicular to them. So for example, this fourth model, I just cut the opposite direction. On this model of 1/3, I'm just going to cut the opposite direction. So 1/3 cut into 2 pieces, making sure that I cut all the way across. I know the answer will be 1/6. Okay, so this is what I would call the grand finale. This is all the notes chunked into one spot. It says I can divide the whole number by a unit fraction or unit fraction by a whole number. Here we go. It says 4 divided by 1/2. Now this equation is kind of like the boss. You just do things in the order that it tells you. So first I see that it says to start with 4. So I would draw 4 wholes. 1, 2, 3, 4. And now I'm going to divide each of my 4 by half. And since I am cutting now, I'm going to draw with a dotted line down. And then when I get my answer, what I'm going to do is just count how many pieces do I have. This would also be a good activity or a good time to reinforce the construction paper. Okay, I want you to grab 4 pieces or 4 strips of construction paper. Let's tear them all in half. How many pieces do I have? Oh, well, I have 8. And here it is, 8. Now, here's the inverse. This is like the best wrong answer or something students will misconceive a lot. So this problem is the boss, and it tells me to start with a half. So to model a half, I need to draw a hole. And then I'm still using solid lines. So here's my hole. And I would also have the students use a highlighter just to kind of emphasize or highlight that we are really just looking at half of this picture. Or half of this model, I should say. And what we're going to do is we're going to take the half and divide it into 4 pieces. So now we're going to cut when we model, using a dotted line. Now, being the math scholars that we are, we need to compare the part to the whole, so always cut all the way across. Don't stop at that line. It's very tempting, but just from the get-go, cut all the way across. So here we have it. One little section is going to be our answer. And so this one little piece is 1/8. And I know our final answer is 1/8. Just another thing to look at, the dividend and the quotient. If you start with a whole number, your answer will be a whole number. If you start with a fraction, your answer will be a fraction. And eventually the kids will realize, well, why don't I just multiply? And they'll start to see the patterns once they've practiced the models enough.